Okay, hello. Today we're going to be looking at applying those trigonometry rules to some actual triangles. You'll notice all three of these are right-angled triangles, and our instruction is to round all the answers to one decimal place. So, all we need to do is to decide which trig ratio we're going to use for each of those. You're going to need your calculator with the trig functions on the calculator, so make sure you've got those at the hand. All right, so to start with, we have to use this angle of 42 degrees. So that means applying to this angle here, the opposite is this side. The hypotenuse is always the one across from the 90. So that means this is adjacent to our 42. Let's label the sides on the second diagram. Everything applies to our 35 degrees. So opposite the 35 is here. Adjacent to the 35 is here. And the hypotenuse is straight across from the 90. You draw up the third diagram and press pause, have a go at labelling up the sides and see how you do it. Right, so this one is the hypotenuse. Now what you've noticed is there are no angles marked on this triangle. So there's your problem. But you are told that it is an isosceles triangle, and the base angles at the bottom of the matching lines, these two angles are the same. So if this one's 90, these two have both got to be 45 degrees, haven't they? So if they're both 45 degrees, we just have to use one of them. So choose whichever one you like. I'm going to use this one. I know it's 45. I'm going to mark that on. That makes this the opposite and this the adjacent. These are the sides we need to find the perimeter. Okay, so now back to our number one. We've got all of our diagrams all labelled up so their sides are ready to be used. Now, here, there's our question. There's the only fact that we have, so we're not going to use the adjacent side. So, keeping our mind on the fact that we need to use SOHCAHTOA. Do you remember SOHCAHTOA? If I have to use opposite and hypotenuse, which rule is that? Opposite and hypotenuse, I'm going to use the sine rule. So we write down the rule. Sine of the angle equals opposite over hypotenuse. In this case, sine of, what's the angle? Sine of 42, so we write our rule. Then we put in our numbers. Opposite is x and the hypotenuse is 7. Now to get the x by itself, remember your basics of algebra. How to get rid of divide by 7? You times by 7. Times by 7. So divide by 7 times by 7 is gone. We're left with x equals, now we just have to get to our calculator. Now you've got to have your calculator. I need the sine of 42, so I type sine of 42. Press equals. Now this long decimal is the sine of 42. I now have to multiply that by 7, and there's my answer. I've been asked to give it to one decimal place, so that'll be 4.7. So over here, 4.7. Excellent. Now my next question. Here we are. We've got all of our sides. This is the one that we're going to use. We've got a number. This is our question. It's got to be in there too. So we're not going to use the hypotenuse. So we're going to use adjacent and opposite. Here's our rules. Adjacent and opposite. Which one? Adjacent and opposite. Here we are. So we're going to use the tangent ratio. So tan of an angle equals opposite over adjacent. Now just put the numbers in. So the tan of 35 equals, so opposite is 12, adjacent is x. Now this one's slightly different. It's a bit annoying because our unknown is on the bottom. So we can't simply, like we did over here, it said divide by 7. So to get rid of that, we times by 7. This one doesn't say divide by 12. That's the common mistake. So we can't just times by 12. We've got to get rid of this fraction form. So let's times it by x, times outside by x. So now we've got the tan of 35 times x equals 12. How do we get the x by itself? How do we get rid of times by tan 35? Well, we divide by tan 35. So they cancel out. We're left with x equals 12 divided by tan 35 degrees. So our x equals 12 divided by tan of 35. Get to your calculator. 12 divided by the tan of 35, close your bracket, equals 17.1377. So to one decimal place, that's 17.1. So x equals 17.1 metres. And that's the length of that one. So now I'm going to clear my board off a little bit. So these will disappear sadly, but I can't fit in my working. So let me just clear the way, 17.1. Right. Now this question here has asked us to find the perimeter of this shape. Perimeter means add up all the sides, doesn't it? So I've had to do some thinking here. I had to use my knowledge of shapes. So once I found one side, the other side is the same. So I'm using my angle of 45. I could have used this one. It doesn't matter. I have to use my known, so I have to use hypotenuse. Now it doesn't matter whether I find the opposite or the adjacent, does it? Because these little dashes mean they're exactly the same. So you can choose. Do you want to use opposite over hypotenuse or adjacent over hypotenuse? Well, for no apparent reason other than I've already done a sine question, I'm going to do a cosine question. So the cos of 45 equals adjacent over hypotenuse. Put in the numbers. Cos 45 equals adjacent, which is the one I don't know, over the hypotenuse, which is 8. Times over by 8. And I get the length of x. So cos 45, cos of 45, times by 8. 5.656 blah blah blah. So to one decimal place is 5.7. Okay, so that's 5.7. Now to answer my, oh, hang on a minute, I'm not finished, am I? So I need to keep all of those numbers. So 5.6568 blah 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 blah, because I'm not at the end of the question. The end of the question says find the perimeter. So I need to use all these numbers. That's one length. The other side was exactly the same, so I'm just going to say times that by 2 and then add on the 8 metres and I have 19.3. So those two sides were the same. Add on the 8 metres and the total length, total perimeter equals 19.3 metres. So this is the way you apply your rules, do your algebra, get your answer. So these are the easiest ones. Next you need to watch, these will get you through the My Maths questions on slide 1. Watch the harder trig questions to give you some pointers on slide 2 and you'll be fine. It's just pretty much like this third question where you just have to use a little bit of your knowledge of triangles to get you going. Okay, good luck.